This video is a special topics presentation on goal function trees as they are used in the systems engineering community. We'll be addressing the use and the application of goal function trees in systems modeling. We'll also be addressing the issues that we faced while creating goal function trees in SysML, specifically using Cameo enterprise architecture. We hope our research will be a springboard for future projects and allow teams to expedite the literature review process.
Before we begin, we want to recognize and thank Dr. Stephen B. Johnson of Dependable Systems Technology, LLC. Dr. Johnson has produced extensive literature on the use of goal function trees in systems engineering, along with applications to NASA projects. It is with his guidance that we have been able to produce our own research. Second, much of the experimentation in SysML builds on the body of knowledge published by Jonathan T. Breckenridge at Marshall Space Flight Center. We recognize and thank him for documenting and sharing his knowledge on the subject. Goal function trees are used to hierarchically represent the different goals of a system. The main objective of a goal function tree is to decompose the overall mission goal into sub-goals, which determine whether the system will be successful or not. These sub-goals can be further decomposed into state vectors and state variables, which form physics-based equations used to describe the physics of the system.
This served to remove the uncertainty associated with natural language, an issue often faced during requirements analysis.
At this stage, goal function trees have been implemented in SysML, a modeling tool used by system engineers. To apply SysML, an architecture software is needed. Common modeling products available today are MagicDraw, Sparks Enterprise Architect, and Rhapsody. For our analysis, MagicDraw Cameo Enterprise Architect was used. To create a tree in Cameo Enterprise Architect, the following steps need to be taken. First, it is necessary to define custom stereotypes to provide additional context to any given element. This method is necessitated by deficiencies in current modeling languages, which will be discussed later. The goal breakdown contains all of the system goals and goal diagrams and is broken up into different packages in order to subdivide the modeling view into smaller, more manageable diagrams. Within the mission success goal breakdown view, we are able to break down the achievement and maintenance goals all the way down into state vector objects, maintaining stereotypes throughout. The functional breakdown view is used to maintain the function packages created during the formation of the goal diagrams. The state vector breakdown is a repository for the system state variable and vector objects used within the goal and function diagrams. The modeling library is the location in the goal function tree where the state variables and vectors originate. Additionally, we were able to simulate the effect of a sub-goal failure as it propagates up the tree. This is shown here using state machines.
The second aspect of our research is identifying issues discovered in the current systems engineering language, SysML. The primary objective of this project was not to produce a goal function tree for NASA. Rather, it was to demonstrate how a system engineer could use Cameo or SysML to create a goal function tree for a similar project. SysML has been selected due to a lack of alternate tools. However, goal function trees are a language of their own, sufficient in their own semantics. At this time, SysML is the closest alternative tool to accommodate the needs of the goal function tree. There is no tool built specifically for goal function trees. At the core of its issues lies interpretation of system terms. Ambiguity in state vectors, function, requirements, etc. lead to bending the rules of each software application. Further, there appears to be no way to represent the model in a single view. Instead, SysML is comprised of 9 diagram views, each with specific rules. Ideally, SysML should be capable of showing a one-level view of all the elements: goals, functions, state vectors, and variables. Large sets of custom stereotypes need to be created to define elements in both Cameo, as shown earlier, and Sparks, as demonstrated by Breckenridge and Johnson. Stereotypes are simply meant to tag elements and are not to be relied on to define elements. In conclusion, our team has used goal function trees to help understand achievements required to reach the ultimate system-level goal, that is, mission success. Further, we explored the language crossover between goal function trees and SysML literature. This allowed us to uncover the roadblocks associated with using SysML to model goal function trees. Thanks for watching. You can watch our other videos, as well as read our full report on the website found in the link in the description.